For decades, humanity has pondered the age-old question, are we alone in the universe? While science fiction often imagines dramatic alien encounters, the first real signs of life beyond Earth likely won't come from flying saucers or extraterrestrial broadcasts. Instead, they may emerge from faint patterns hidden in the light of distant stars as it filters through alien atmospheres, a method subtle but powerful. One recent candidate drawing scientific attention is the exoplanet K218b. Located around 124 light-years from Earth in the constellation Leo, K218b orbits a cool red dwarf star and resides within the so-called habitable zone, where conditions might allow for liquid water. This planet, roughly 2.6 times Earth's diameter and about 8.6 times its mass, straddles the line between what scientists call a super-Earth and a mini-Neptune. Initial observations made by the Hubble Space Telescope suggested the presence of water vapor in the planet's atmosphere, an exciting possibility. However, Hubble's capabilities in the infrared spectrum are limited, and the interpretation remained inconclusive. That changed when the James Webb Space Telescope, JWST, with its more sensitive infrared instruments, took a closer look. In 2023, JWST made new observations using its NIRISS and NIRCam spectrometers. The results confirmed the presence of methane and carbon dioxide, both of which can exist in lifeless planetary atmospheres. Surprisingly, no water vapor was detected in the upper atmosphere, contradicting Hubble's earlier hints. However, a much more intriguing signal appeared: a possible trace of dimethyl sulfide, DMS, a molecule that, on Earth, is almost exclusively produced by living organisms, especially marine phytoplankton. The detection of DMS sparked excitement in the scientific community. Could this be the first chemical hint of alien life? Unfortunately, the signal was extremely weak. At just a 1 sigma confidence level, meaning there's about a 1 in 3 chance it was just a random fluctuation in the data. In scientific terms, a 5 sigma level is needed to claim a true discovery. Still, the mere possibility of detecting a biosignature molecule like DMS encourages further study. Beyond the search for alien life, K218b itself is scientifically fascinating. It appears to be a Hycean planet, a newly coined term describing worlds that have both a global ocean and a hydrogen-rich atmosphere. If the atmospheric models are correct, K218b may possess a thick hydrogen layer above a vast, possibly liquid water ocean. This structure could explain the absence of water in the upper atmosphere. Any vapor might condense and rain down before reaching the heights observable from Earth. The potential lack of ammonia, which would be expected in a thick hydrogen atmosphere, also aligns with the Hycean model. An ocean might absorb ammonia from the atmosphere, further supporting the ocean world hypothesis. However, these ideas are based on complex models, and alternative interpretations may also fit the available data. Even if K218b hosts liquid water, that doesn't guarantee it's habitable in the way Earth is. The deep pressures beneath the hydrogen atmosphere might push water past its critical point, a state where liquid and gas become indistinguishable. In such environments, no clear ocean surface exists. Moreover, intense pressure could form high-pressure ice layers beneath the ocean, isolating it from the rocky interior. This separation may prevent geochemical cycling and hinder processes like plate tectonics, which are believed to play a crucial role in sustaining life on Earth. In our search for life, scientists consider not just the presence of water, but also energy gradients, chemical building blocks, and a stable environment. On Earth, life may have started near hydrothermal vents at the ocean floor or in shallow tidal pools. If K2-18b lacks solid surfaces interacting with its ocean, the origin of life becomes more speculative. So what's next? The scientific community eagerly awaits future JWST observations, particularly those using the MIRI instrument, which can observe in mid-infrared wavelengths up to 28 microns. These longer wavelengths may help separate the signal of DMS from other overlapping molecules like methane. With more data, scientists will either confirm the DMS detection or rule it out as a statistical anomaly. Additional unexpected molecules could also emerge, providing new insights into this strange and distant world. Regardless of whether K218b harbors life, It marks a major step forward in exoplanet science. Thanks to telescopes like JWST, we can now study the atmospheres of distant planets in unprecedented detail. Each observation brings us closer to answering one of the most profound questions in science. Is life common in the universe, or are we truly alone? It's rarely aliens, but one day it just might be.